Hello everyone, I am Siddharthan. In my previous videos, I have explained you what is the intuition and math behind a k nearest neighbor model, and in those videos we have seen that finding the distance between 2 points is very important when it comes to a KNN classifier. So the two distance measure that we will be using are Euclidean distance and Manhattan distance. So in this video, let's try to understand how we can write functions in Python in order to find this Euclidean and Manhattan distance between 2 points. Okay, so understanding this will help us a lot when we are trying to build this KNN classifier model from scratch in Python. Okay, so that's the reason for having this particular video, and let's get started. So I'll open my Google Colab setup. So first of all, we have to import this NumPy library. So this is the formula for Euclidean distance. It's d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, and this is the formula for Manhattan distance, which is d is equal to modulus of x1 minus x2 plus y1 minus y2. So we have discussed about these formulas in my previous videos itself. So first of all, let's try to create two data points and we will try to find the distance between them. Okay, so I'll write a comment here as consider 2 points with two dimensions. Okay, so the two dimensions are my x-axis and y-axis. So totally we have two dimensions in this point. So let's consider the first point to be p1, and the coordinate for the point p1 are 1 comma 1, and the coordinate for p2 are 2 comma 2. Okay, so these are my 2 points. So we have considered the similar example in the previous videos itself, where we have taken 2 points A and C, and the coordinate for the point A is 1 comma 1 and the coordinates for the point C is 2 comma 2. So you can consider this 1 comma 1 as x1 comma y1 and the point 2 comma 2 as x2 comma y2. So you can see that here, and if you plug in the values in this Euclidean distance formula, you will get the Euclidean distance value as square root of 2, which is the distance between these 2 points. So we have to implement this formula in Python so that we can get this particular value. Okay, so this 1 comma 1 is my x1 and y1, and this 2 comma 2 is my x2 and y2. Okay, and this is the formula that we have, and we can calculate the Euclidean distance now. So I'll write a comment here as calculating Euclidean distance. So we will try to find this distance between the 2 points p1 and p2. Let's create a variable called as dist, so which represents distance. So first of all, we will try to find this value x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so how we will be creating this is p1 with index 0 minus p2 of index 0 whole square. Okay, so this particular term represents x2 minus x1 whole square. Okay, so when you represent p1 of 0, it means first value in my list p1. Okay, so the first value is nothing but 1, and we are taking the first value of p2, which is my value 2. Okay, so we are just writing this particular term x2 minus x1 whole square in terms of Python, and we have to add y2 minus y1 now. So how you can do that is, so plus p1 of index 1 minus p2 of index 1. So this should also be squared. Okay, so this is nothing but, so this term represents my y2 minus y1 whole square. So when you represent the index 1, the second term will be taken. So the second term is nothing but my value 1, and the p2 of 1 is this 2 value, so whole square. So distance is equal to p1 of 0 minus p2 of 0 whole square plus p1 of 1 minus p2 of 1 whole square. So this is the term that is within this square root. So in order to find the Euclidean distance, you have to take the square root of this, right? So I'll create another variable called as Euclidean distance, and this Euclidean distance is equal to np dot square root. So sqrt, so this is the function which will give us the square root of a value. So we have to find the square root of this distance, right? So this will give you the Euclidean distance, and let's try to print this value as well. So print Euclidean distance. Okay, so let's run this, and you can see here the Euclidean distance value between the 2 points is 1.414. So this is nothing but square root of 2. So the value of square root of 2 is 1.414, right? So this is how you can get the Euclidean distance between 2 points. So this is a point in 2 dimensions. So instead of saying this as a point in correct terms, it is nothing but a vector. Okay, so now let's try to understand what if the point has 3 dimensions. So let's say that we have x-axis, y-axis, and z-axis. So I'll just copy this. So now let's try to do the same for a 3-dimensional point. And So this also remains the same with a slight change. So now let's consider three dimension. So you can consider this as, so this formula will become x2 minus x1 whole square plus y2 minus y1 whole square, plus there will be another term which is z2 minus z1 whole square. So let's add another coordinate to it, which is 1. So you can just consider any point. So here I'm just considering simple points. So you can change these values as well. So there is one change that we have to do here. So this should be, again, so we should add another term which is p1 of 2 minus p2 of 2. So this should be squared. Okay, so this is my last term. So this particular term represents, so this 1 minus and this 2. Okay, so this is the difference between them. And when you run this, you will again get the Euclidean distance, but this is the distance between the point in 3 dimension, and the value is 1.732. Okay, so that is a site where you can find this Euclidean distance and Manhattan distance. So just search as Translators Cafe Euclidean distance calculator, and you will see this site. Okay, so in this you can give some points and try to find the Euclidean distance between them. So I'll click this 3D. Now we have three coordinates here. So the points that we considered as are 1 comma 1 comma 1 and 2 comma 2 comma 2, right? So I'll enter 1 here. So 1 1 and 1 and 2 2 and 2. Okay, so you can calculate this. It will give you the Euclidean distance, Manhattan distance, and this Chebyshev distance. So here we are interested only in the Euclidean distance and Manhattan distance. So this value is nothing but 1.732, which is basically the square root of 3. So you can see this 1.732 here. So this is how you can find this Euclidean distance. So the problem is, so in machine learning or data science, we will be dealing with the data set with huge number of values, right? So you can see this data set here. So I have taken this sample data, so which is used to predict whether a person has a person has heart disease or not. So you can see here this contains multiple columns, right? So it doesn't contains 3 or 4 columns. So we have to create a generalized form in order to find this Euclidean distance. Okay, so for this we will be creating a for loop where you can give multiple values. So you can have any dimensional data. So in this case, we have only 2-dimensional data. So in this case, we can only find the distance between 2 points for 3-dimensional data, right? So now we are going to generalize it, where we will be creating a for loop where you can give points with any number of dimensions. Okay, so let's just copy the same thing. Yeah, so I'll just copy the entire thing, or else the first two things is sufficient. Okay, so now we are considering points with 4 dimensions. So we won't be doing the same thing again, but we are going to create a for loop. Okay, so first I'll create this variable dist and I'll give the value as 0. So we are initiating this variable as the value 0, and we are creating a for loop. So for I in range length of p1, so length of p1 and distance of, so sorry, this distance is equal to distance plus p1i minus p2i. Okay, so now we have to come outside the for loop and write Euclidean distance is equal to np dot square root. So you can also use the square root function from math library. So in the next video, where we will be trying to build knn from scratch, so we will be using only numpy library. So that's why I'm using square root function from numpy library. So square root of distance. So I'll explain you what we are doing here. So just a second. So print Euclidean distance. Okay, so let's try to understand this code. So we have 2 points here with 4 dimensions. So we have basically 4 coordinates. So it can be x, y, z, and another coordinate. So similarly, so the first point is 1 comma 1 comma 1 comma 1, and then we have all the values as 2 in the second point. So you can consider any points here. So we are initiating this distance value as 0, and we are creating a for loop. So this for loop will run the number of times that is equal to the total number of data points that are present here. So you can see here this point contains 4 dimensions, right? So this for loop will run 4 times, and each time it will try to find the difference between the first value and this value. So first time this for loop runs, it will try to find the difference between this 1 and this 2, and that value will be squared. Okay, so I have to mention square here. So Yeah, squared. So the second time it runs, it will try to find the difference between the second coordinate, in the corresponding two data points. So this will be carried out until all the data points are run and the difference has been found. Okay, so that is the reason for having this for loop. So this length of this p1 will be 4 because it contains 4 values, right? So this is how we can simply create a for loop where you can find the Euclidean distance for any number of values. Okay, so I'll run this. So the Euclidean distance in this case is 2. So you can also substitute the values here. So you can just click this 4D and you can give the values as 1 and 2. So it will give us the Euclidean distance as 2. So this is what we get. So this is how you can find Euclidean distance for data points with any number of dimensions. So we are just going to do one more thing where we will be creating a function in order to find this Euclidean distance. So I'll just create a text here as creating a function for calculating Euclidean distance. Okay, so def is the keyword in order to create the function which stands for define. So let's name this function as get Euclidean distance. Get Euclidean distance, and we have to give two values which are p1 and p2. Okay, so we just have to put these things together in this particular function. So let's copy all these things and paste it inside this function. Okay, so make sure the indentation are same, so you can refer the indentation here. So the distance and for loop should be in the same indentation, and this distance, this particular line should go inside the for loop, and this Euclidean distance should be in the same line as this for loop. Okay, so this indentation is very important. So we are just doing the same thing, but we are creating a function for this. Now you can call this function in order to find the Euclidean distance between any points. So I'll just copy this get Euclidean distance function here, and between this you just need to give the two data points. So the first data points that we'll be considering this is the four values that we have. So 1 comma 1 comma 1 comma and 1. So this will be 2 comma 2 comma 2 and 2. So this basically contains 4 dimensions. Okay, as you can see here, the distance is 2. So this is how you can get it. So you can also change the dimensions. Okay, so now let's consider the data point with 3 dimensions. So let's run this. Okay, so we know that it is square root of 3, which is 1.732. So this is how you can create a function in order to find the Euclidean distance between the two data points. So the one thing that you need to remember is the two data points should have same number of dimensions. So you cannot use or you cannot find the distance between the point in which one data point has 3 dimension and one data point has 4 dimensions. So it won't be working well. So we should have the same number of dimensions for both the data points. So now we will be doing the same thing for this Manhattan distance. So the only difference is that we have to change this formula. Okay, so I'll just copy the entire thing and put it here. So yeah, so here we'll be creating a function for Manhattan distance. So creating a function for Manhattan distance. Let's paste that here and let's rename this to Manhattan. Okay, so Manhattan distance, and this formula should be distance plus absolute value of p1 minus p2. Okay, so we should remove this square, so we don't have a square term here. So if you consider the previous case of Euclidean distance, we have to square the difference, whereas in this case we won't square it. So we will try to find the modulus of it so that the negative term doesn't get ignored. So I'll just show you here, like if you use this absolute function. So there is a function in Python called as absolute, which is represented by abs, and if you give some negative value to it, so let's say that absolute of 1 should be 1, right? So it will just ignore that negative sign. So if you try to find the absolute value of 1 minus 2, so when you subtract 1 minus 2, you will get the value as minus 1, right? So when you put that in this absolute function, you will get as 1. So we need to remove that sign. So in order to find this modulus, we'll be using this absolute function. Okay, so I'll just write a comment here as absolute, which basically represents, so it gives the absolute value of some difference. Okay, so we just need to change it. So this Euclidean distance, we can rename this to Manhattan distance. I'll copy this and put it here. Okay, so distance, first we are initiating the distance value as 0. So this for loop will run the number of time, or the same number of dimensions that has. If a point has 3 dimensions, this for loop will run 3 times. If the data point has 5 dimensions, it will run 5 times, and so on. So this is the formula in order to find this Manhattan distance. Okay, so the first time it runs, it will try to calculate this x1 minus x2 value. So the second time it runs, it will try to find the value for this y1 minus y2. So let's run this and try to find the Manhattan distance. And you can call this function in order to get the value. So I'll copy this get Manhattan function here and put it here, and let's try to find the distance between them. And here also we will consider the same data point. So let's say that the data points are 1 comma 1 comma 1 comma 1, which basically contains 4 dimensions, and 2 comma 2 comma 2 comma 2. Okay, so this will give us the Manhattan function. So if you come here, you can see the Manhattan function value as 4. The Manhattan distance value is 4, which is equal to this. Okay, so we are making a mistake. Yeah, so we shouldn't find the square root, right? So the square root is present only in the case of Euclidean distance. So we should remove this particular line. So this is the error that we have. So now we can run this. Okay, so this, we should just rename this distance. So let's say that Manhattan distance is equal to dist. Okay, so now you can see here the Manhattan distance value is 4. So you can also see that the Manhattan distance value between the points, between these 2 points is 4. So you can just plug in the values of different data points and try to find those values. Okay, and now what we are going to do is we are going to take a sample data set, and we are going to find the distance between 2 similar data points and the distance between 2 dissimilar data points. So you can see this data set here, and this data set is used in order to check whether a person has heart disease or not. So we have already worked on this use case in our channel. Okay, so you can see here this last value is the target column. So it basically contains the target as either 1 or 0, where 1 represents a person with heart disease and 0 represents a person without heart disease. Okay, so if we consider 2 data points with the target 1 and 1, so it basically means the 2 data points are similar because 2 people have heart disease. If you try to find the distance between the first point with target 1 and another data point with target 0, so in that case the distance will be large. So let's try to understand this. So we are going to use the functions get Euclidean distance and get Manhattan distance in order to find this difference. So yeah, so I'll create a comment here as distance between two similar points, 2 similar data points, and let's try to print get Euclidean distance value and Manhattan distance. So let's try to find both this distance as well. Sorry, so get Manhattan distance. Okay, so within this we need to plug in the 2 data points. So first of all, I'm going to take the first 2 data points. So these 2 data points have the target as 1 comma 1. So the distance should be very less. So if the distance between 2 data points are less, that means the 2 data points are similar to each other. If the distance is large, then it means that 2 data points are different from each other. Okay, so I'll consider the first data point here. Okay, so we shouldn't include this target. So this basically represents our label, so we should not include that. So we should include all the data points except this target column. So I'll paste it here. So this is my first data point, and my second data point is this, the second point. So let's take this. So both of these represents person with heart disease. Okay, so I'll paste it here, and I'll just copy the same thing and paste this within this one. Okay, so the first line of code will give us the Euclidean distance, and the second line of code will give us the Manhattan distance. Okay, so you can see here. So yeah, so the first value is 50.64 and the second value is 100.2. Okay, so the Euclidean distance is 50.6 and the Manhattan distance is 100.2. Now we will try to do the same thing for other 2 data points. So in this case, we will consider the data point with target 1, and the second data point will consider the target 0. Okay, so in this case, these 2 data points should have a larger distance between them. So that's the idea. So I'll just go to my collab and I'll just paste all these things here. Okay, so I'll just remove the second data point. So we are going to change this data point alone. So yeah, this one also. So this basically means two, dissimilar data points. Yeah. So I'll just copy this data point which contains the label as 0. Okay, so the distance should be large compared to the first Euclidean and Manhattan distance. So I'll paste it here. So let's try to see what is the distance between them. Okay, so let's try to run this. You can see here the Euclidean distance is 69.5 and the Manhattan distance is 124.8 because these two data points are dissimilar. So this data point has the label 1 and this data point has the label 0. Whereas if you consider the first case, this data point has the label. So this data point has the label 1 and also this data point also has the label 1. So in this case, the distance is pretty small, whereas compared to this particular case where the two data points are dissimilar, the distance between them is very large. So this is the inference that you need to remember. If the distance between two data points are very large, then that means the two data points are dissimilar. Whereas if the distance between them is slightly lower, then it means the two data points are very close to each other, or it basically means two data points that are similar to each other. So this is how you can find the Euclidean distance and Manhattan distance. So I'll just give you a quick recap of what we have done. So this is the formula for Euclidean distance, and we have created a simple function which we can use in order to find the distance between two data points with any number of dimensions. Okay, so this is the function for calculating the Euclidean distance, and it is pretty simple for calculating the Manhattan distance as well, which is modulus of x1 minus x2 plus y1 minus y2 and so on. So this is the function for calculating the Manhattan distance. Okay, so and finally we took two data points where the two data points are similar in the first case and the two data points are dissimilar in the second case, where we have seen that if two data points are similar, then the distance will be less, and if two data points are dissimilar, then in that case the distance will be large. So the reason we are doing this is when we are working with a k nearest neighbor classifier, it will try to find the distance between the test data and the training data. So it will try to find the close neighbors. So how we can, it will find the close neighbors, or in other words, it basically means nearest neighbors. So it will try to find this Euclidean distance between the data points, and it will choose let's say that the k value is 5. So in that case, it will try to find 5 data points that are closer to the test data, and it will try to say it belongs to which class. So this is how basically k nearest neighbor works, and this is the importance of finding this Euclidean and Manhattan distance. So in the upcoming video, we will be using all this in order to build a k nearest neighbor classifier, where if we try to give a test data, it will try to find the distance between the other training data, and it will tell us to what class does it belong. Okay, so that's it from my side for this video, and I'll see you in the next upload where we'll be building this KNN classifier model from scratch. So I'll see you in the next upload.